Okay, today we're on lecture number 21. We're going to be talking about UMLs. Let's see, Tyler, that's correct. Only slides today. We're going to be actually drawing a UML later. We're going to look at the code that we drew, that we wrote up on Friday, and then we're going to draw a UML for that code. So we looked at pet store UML on Friday, okay, over here in NetBeans. We're going to take that code and then draw it in a editor online. It's called Draw.io. So you'll want to open up the slides. You'll also want to open up Draw.io. Okay, Draw.io. We're going to be using it here in a second. First, we'll hit up the slides. So if you open those up, you'll want to take down some notes. For UML, it's, you'll want to understand what's the language, what's the purpose of it. There's probably one question that asks you what the overall, concept of UML is. But the most important thing for the exam is actually drawing a UML. So you'll want to take these concepts and then apply them and actually draw a UML for the midterm. Okay, so the midterm is online, but you'll essentially come back over here to Draw.io and draw the UML for the midterm, and then submit a URL for it. Okay, which we'll talk about a little bit today as well. Okay, so first the slides. You want to know what UML stands for. So it's Unified Modeling Language. Okay, it's a very important concept for the industry. A lot of times, you don't spend much time implementing. If you've taken software engineering or you're about to take it here soon, you'll see that implementation for code is actually only, I think the textbook says, what, 15% or 10%? I would say more realistically, probably 20%. So 80% you're just designing the code, thinking about what you're going to do, thinking about designing the system. Once you have the system designed, then you actually go and implement it. So if you have, let's say, a week to develop the system, you should spend at least 80% of your time designing it, and then the last few days you actually implement it. But you'll get more into that when you get into software engineering. How you design the system is where UML comes in. So when you're designing the system, you should draw a UML diagram to think about how the system works. So how do people write down software architectures? Well, UML. So here's an example of what you're going to see. This is a really high-level example, but let's say I'm creating a program to keep track of people at the university. Maybe I want to keep track of people at the university. So I may have a person, and then I may have that may have common elements, like person usually has a name, a person usually has an age, a person usually has a gender. But then I may have a Mizzou student that extends person, and the Mizzou student may have something specific like a student ID or a paw print. And then a 3330 student may have something very specific like grade in the class, attendance, challenge 1, challenge 2, challenge 3, whatever. Same for anything. So let's say I have a cell phone company. Maybe I have Verizon Wireless, or maybe I have a cell phone and GPS satellites, and then Verizon Wireless. So you can imagine building the system and thinking about it before you've actually even implemented any of the code. Okay, so some of the big question is, do people use it? Do people really use it? Should I even bother learning it? And then if you are convinced that this is important because they are using it in the industry, then you may have questions like, well, what is a class diagram? What information goes into it? How do I create it? When should I create it? So again, you're going to have this design phase when you're building a system. That design phase, you're going to specify the structure of how the software system will be written. You're also going to specify how it should function. And that's actually without writing any implementation. So usually, let's say at Google, you're going to be doing this beforehand. You're going to have a team. You're going to talk about the system. You're going to talk about what features should go in it. You're going to talk about how it all should be connected. Then when you guys have a plan and you know what you should do, then you actually go and implement it. And a lot of times, most of the design phase will be implemented by your supervisor. So you have a manager, they'll kind of design the basics of the system, and then they'll need your help to get more of the specifics on what should go in the system. So it's really a transition from what the system must do to how the system will do it. For example, for object-oriented, what classes will we need to implement a system? What fields, what methods? How will they interact with each other? Like model view controller. Okay, so how do you design a class? We're going to be drawing these here in a little bit. We're going to be using class diagrams. That's the most important one for object-oriented programming. You know, classes for the project, let's say you have a system, so class identification, you know, usually you'll have classes that are nouns, and the verbs are usually methods. Okay, we talked about that in naming conventions. So on a class diagram, you usually have the class name up at the top, and you'll usually talk about some key variables that you may need, as well as some methods. So you remember we have states and behaviors. Okay, usually you'll have responsibilities, collaborators. Okay, now UML just doesn't do class diagrams. It's a huge system. So UML can take a picture of what an OO system should be, operating system or object-oriented programming system. You know, programming languages themselves aren't abstract enough for object-oriented design. So let's say I bring some code up to my manager. I say, okay, here's some pseudocode, and this is what the system should look like. Well, usually your manager is a business person. It may be a business person. It may be just a regular engineer. Sometimes the managers actually don't know code that well. They may know it a little bit, but not like the program, you know, not like the programming engineer. So if I just bring up code or pseudocode, they're not going to know what that means. You need to have it even more generic. So UML is usually the open standard for drawing pictures of an object-oriented system. Okay, it's usually the standard. So it's really high level. You're going to see that here in a little bit. It's just a sketch or a blueprint. You know, you don't really talk about what goes in the method. You just say that this method is going to be there. And then once you're presenting your system, you can talk about what the method will do. Let's see. You'll want to know some history, like who developed it. Okay, you want to know some history. So we have Grady, Jim, Ivar here. I'm probably saying that wrong. Okay, came up with the system back in the 1990s. And there's a lot of them. If you ever look up UML, okay, we're going to be looking at unified modeling language, but they actually have union of all modeling languages as well. So they have class diagram, objects diagram, sequence, activity diagrams. There's so many diagrams. You'll see ... There's probably 50 of them. I'm not sure exactly how many are in this, but they have a lot of them. The ones that are highlighted here are important for object-oriented programming. So the most important one is this class diagram. It's going to be a picture of the classes in the object-oriented system, their fields, their methods, the connection between the classes. Things that are not in a UML class diagram or details on how the classes interact with each other, or algorithm designs. If I go up to my manager who's a business person and I show them an algorithm, they're going to be scratching their head. They didn't study algorithms like we did. Okay, so you don't want to put that in there. You just say, I'm going to create this method. You could talk about it's going to use this algorithm, but how it's actually implemented is left out. Okay, so we took a look at classes at the beginning of the semester. Remember, a class represents a discrete concept within an application being modeled where it represents a particular kind of thing. So it could be a physical thing like an airplane, or it could be a business thing like an order, logical thing like a scheduling system, an application thing like a cancel button, a computer thing like a hash table, or a behavioral thing like a task. So an object can be anything. We saw that the object for 3330, it's just a blueprint. Okay, class is a blueprint. So a class is the set of objects with similar structure, usually states and behaviors. Remember states and behaviors from the beginning. Okay, class can also be an individual concept. So you want to go through some of these. These are important just to understand, just to go back to remember what classes are, how we're using them in OOP, states and behaviors. Okay, you'll see it right here. An object is a discrete entity with identity, states, and behaviors. Okay, we kind of went over it. So this is more important, I think, for this lecture. Let's look exactly how a class diagram should be. So first, up at the top, you're going to have a class name. Okay, you usually have a class name up at the top. This is a real UML diagram. So this is a UML class diagram. You're going to have your attributes, and notice how they do it. They put the name here at the beginning, and they put the type. So I have, and the access modifier is not shown here, although you can specify the access modifier as well. But I have a class field named series, which is a type string. I also have a price category, which is a category. Category is not a regular class, so that's usually going to be your own custom class. Then I have a number, which is an integer. Here's my operation. So I have class name, attributes, operations. So class name, fields, and methods. I have a method called cost, which will return money. I have a method called reserve, which takes two parameters. You'll see this one had no parameters. This one takes two parameters. One is series, which is a string. One is level, which is seat level. And then I have a cancel method, which doesn't return anything and also doesn't take any parameters. You notice this class is in a box. So a class has a unique name within its container. So it's in this box here, which is usually a package, but sometimes another class. Okay, the class has a visibility with respect to its container. We're not going to really look at containers because all the code that we're going to draw is going to be in one package. But in some cases, you'll also have packages here as well. So this is what you're going to want to know. What are all these key things that I need to do? So here's just a regular class. Up at the top, you'll see it's in bold with a capital letter because I'm following naming conventions. But if it was an interface, I put the interface annotation up at the top. If it's an abstract class, it'll be in italics. However, it's really hard. Before, we used to draw this by hand. And for our midterm, students would draw the UML by hand. And it's really hard to write italics by hand. So I would also have students put the abstract annotation at the top of the class statement. I actually recommend you do that even though we're using the program. You'll see some of this may be italicized here, but it's hard to see. So by putting an abstract annotation as well as being italics, it's easier for the TAs to see. So I recommend that. So if it were me listening to this right now, I would take a little note and say, for the midterm exam, put an abstract annotation to refer to it, an abstract class or even an abstract method. Okay, you'll see interface methods should be there, operations in a method. Okay, abstract methods will be overridden by the descendant. We'll look at that. Here's some things you need to do. So for public, it'll be a plus symbol. For protected, it'll be a hashtag. For private, it'll be minus. For the default, it'll be a tilde. Derived, we're not really going to use, but it is an option. You'll see here's how you set up a field. So you set the visibility, which is the access modifier. See minus is there, so those are private. Then you put the name. The name is called width. Then you have the type. Type is an int. And then if you had an array or a default value, it also specify that as well. So I could say this is a private variable called width, and the type is a primitive data type called int. And then I could do an equals symbol equals to 1.0 or 1 equal to 1 since this is an int. So I could say equal to 1. Maybe as the default value. You'll see static variables are underlined. Okay, static variables are underlined. And here's an example of one with the default value. So here's a private, this is a private field called balance. The type is double, and the default value is 0.0. Okay, same with the methods. You'll see this is a protected method. It's called getID. It takes no parameters, and it returns an int. You'll see this one's underlined. This method here is underlined. So this is a static method, and this is a static field. Let's see, is it also a requirement to boldface class names? That's correct. Class names will be bold. Interfaces will be bold. Let's see. I believe the program does that for you automatically, but you will want to try to check that. Make sure these are bold up here at the top. Make sure you have a box. Even if I had no fields, let's say I had no fields, you would still see a box for it. It just may be empty. Okay, you'd still see a box for it. It may just be empty. Some people will remove it in the industry. You won't see a box for the fields. You'll just see a box for the methods. The way that you can differentiate between the two is methods always have parentheses, whereas fields do not. But I see a lot of people, they'll still have the box here. It'll just be empty. It'll be really small, maybe like one line. It'll be empty to show there's no fields and then just methods. Okay, same with the methods, same access modifiers. Okay, so you see public, protected, private, and default. Method is the same, visibility, followed by the name, followed by the parameter list, followed by the return type. Okay, so you see this example here. Here's a public method called distance. It has two parameters, P1 and P2, which are type point, and it will return a double. Okay, you'll see there's some things that you'll want to know. Usually UML diagram will contain the least information as possible. So for example, if these methods return void, then I don't need to put anything there. I don't need to put void there. By not putting a return type shows that it's void. So you'll see here, you omit the return type on constructors and when the return type is void. So we don't need to show unnecessary information. You'll see this is a constructor here. How do I know it's a constructor? Because it's a method with the same name as the class. Okay, that's a rule that we learned earlier. Constructors have the same name as the class. This one takes two parameters, width and height, which are ints, and this constructor will set the default value for these private fields up at the top. I mean, those are just basic class diagrams, how you implement them. There's also relationships between classes. You have generalization and association. Generalization is usually an inheritance. Could be inheritance between classes. Could be an interface. You also have association, which is a usage relationship. We'll talk about that here in a little bit, but here's a more detailed structure here. So here's an interface. You see the annotation. Here's an interface called shape. You'll see the empty box like I was talking about earlier. Here's an empty box for the fields. So there's no fields in this interface, but I do have a method called getArea. Now, you'll notice here, if I come back up to the top, it says that abstract elements are italicized. That would be an abstract method or an abstract class. If I come down here to this interface, this is an abstract method. But in an interface, they're abstract by default. So I do not need to italicize it in an interface. But you'll see it's italicized here in this class. So since this is an abstract method with the abstract keyword, then it needs to be italicized, as well as the class name. So you'll see rectangular shape is an abstract class, which contains an abstract method, which is called contains here. You'll see get areas up here in the interface. I wish I could highlight it. Get areas up here in the interface. Let me draw it here. Maybe this is better. Let's see, draw. You'll see get areas up here in the interface. It's also down here in the subclass. That's how I know it overrides. So this get area down here overrides the one in the interface. So that's how you show the override annotation. This method here is abstract. So it's italics. This class name is italics. You'll see here I have contains. It's also down here, contains. So the one in the subclass overrides the one in the superclass. Okay, so this one's italics, this one's not, this one's abstract, this one's the implementation. Now notice the relationship here. You'll see these arrows here. These are the relationships. So you see the dotted line, that's implements. Solid line is extends. Okay, so this is the implements, this is the extends keyword. Let's see. I talk about generalization, you're going to want to read it. But here's what it looks like. So here's an abstract class up here at the top. Okay, abstract class. You'll see it has a field and a method. The way that you show that it overrides is you also write the method here in the subclasses. So you'll see this arrow here. This is the keyword extends. This is an abstract class. Remember, if I inherit from an abstract class, all the methods in that abstract class that are abstract must be overwritten. They must be defined. So if I want my mail order to be an order, I have to write the confirm method here, which I did in both of the subclasses. So that's how you show the override. There's other relationships, one-to-one, one-to-many. We're going to actually look at these association types. We're going to talk about them here in a little bit. We're running out of time. I actually want to draw some stuff today. So that's good enough for the slides. Let's come over here to draw IO. So now this UML.pdf is going to be very important. Okay, it's going to be very important for your midterm exam. This is kind of like a study guide. So I give you static members are underlined, abstract elements are italicized. You'll see I have the access levels here. I have public, private, protected, and default. Those are the ones that we use. I give you examples of how to write a variable or a field and a method. I tell you how to write a constructor. So in the example on the slides, they didn't use the constructor annotation, but in this class we will. We'll use the constructor annotation. You also have an interface annotation. There's also an enumeration annotation. Let's see, the file is still locked. Let me give it a look. That's a very important file. Yes, it is. Let me open it up. Okay, it's opened up now. Try to access it. Okay, now these annotations that I'm talking about, they use these funny symbols. These are not less than or greater than symbols. These are special symbols. I've actually provided them down here, but on the lecture after this class, it tells you how to use them. So I go down to lecture. On Mac, it's really easy. It's Option / or Shift Option /. On Windows, you click the Alt key and literally type 174. So you click Alt, type 174, let go. Then you type Alt, hit 175, let go. But Windows users need the keypad. You need a keypad. I've heard you need a keypad to do this. Most laptop users do not have a keypad. So you can literally copy them here if you need them while we're doing them in the class. So we're going to do this from the code that we wrote last time. So I'm going to go over here to Draw.io. Okay, so go to your web address, Draw.io. This is the tool you're going to be using for the midterm exam. And you'll see save diagrams to where. I'm just going to save them here to my device. And I'm going to create a new diagram. Okay, I'm going to create a new diagram. If you can just create just a blank diagram here. Select blank diagram, which is the default, click on create. If you want to save it, you can. We probably should. You could choose your lecture directory. Okay, we're in lecture 21. I already called it UML before. We should have said Pet Store UML on lecture 20. Lecture 20 should be Pet Store UML. This one is truly UML. And then you could just say, this is our pet store UML.draw.io. Is doing the UML going to be part of the timed or untimed midterm? It's going to be part of the timed midterm. Okay, it's going to be part of the timed midterm. So you'll have 50 minutes. Since we're online, I may try to give a few extra minutes, maybe like 55 or 60 minutes. But you'll have essentially 50 minutes to draw UML and then to answer multiple choice questions. The UML will be small. There'll be maybe 3 classes or so, maybe an interface in there. So you should get it done pretty quickly. But the key to getting it done quickly is to know how to draw a UML. If you're sitting there and you don't remember, oh, how do I do an abstract element? Oh, how do I do a public, private, protected? Then it's really going to slow you down. If you know public is plus, private is minus, then you'll be able to draw very quickly. The midterm does lock the browser, but you will be able to come to Draw.io. Okay, so everything will be set up and you'll be able to come to Draw.io. That's the only page that you'll be able to come to. Okay, good questions. Okay, in this Draw.io tool, you want to get familiar with it. That's another thing that would slow you down in the midterm if you don't know how to use this tool. So you'll want to make sure you use this tool and really get familiar with it in your midterm. So the next challenge, I'm going to release it this afternoon, probably late evening tonight, I'll release this next challenge. It's to draw a UML diagram. So while you're drawing it, take your time, learn the tool. That way, when the midterm comes, you already know how to use it. So a class diagram in here, if you open up UML, it's the third one. So if I drag this over, drag and drop, you'll see it sets up, and it kind of helps you a little bit. Sets up the bold class name. It sets up a default parameter plus with the field name and the type. So it actually tells you a little bit, so that will actually help you. So I come back over to the code. I'm going to be switching back and forth a little bit. I'm going to draw the first one's pet. So if I open up pet, you're literally just going to start at the top and work your way down. So I'm going to draw pet. You'll see pet is abstract. If I come back over to our UML PDF, Okay, it says abstract elements are italicized. Now, remember, even though it's easy to do italics here, so let's say I do pet, I'll do capital P-E-T, capital P to follow the naming convention. If I come over here to the right, you can see I can italicize that over here on the right. And yes, it is kind of noticeable. But again, for the midterm, the students used to write it by hand. I recommend you also write it here in the program. You'll see this little red or this little orange circle. Move it down a little bit. Come over here in front of pet, hit enter to move it down. And then at the top, do those little special symbols. So on Mac, it's Option \. On Windows, it's Alt 174. On Windows, if it doesn't work for you, come over here to Lecture 21 and scroll down to the bottom. I have them down here. Okay, at the bottom, you'll see I have those little symbols down here. You can copy and paste them. So for example, I'm going to copy the close tag. Come over here, I'm going to paste it. You'll see it's a little bit different, I guess, because I copied it, but that will work. What you should not do is these. Do not do less than and greater than. Make sure you do the symbols. You'll see the symbols are much different than less than or equal to, less than or greater than. So don't do those. Do the symbol. And then actually put abstract here. Okay, this will all be italicized. So select it all. You can do a Command A and make sure it's all italicized. Okay, in the UML PDF, it doesn't tell you to do this. And in the slides, it doesn't tell you to do this. This is a recommendation by me, so the TAs won't miss your elements here. Okay, so make sure you're doing this on the midterm and on your a challenge that I'm going to release later this evening. The symbol on the midterm, you will need it. Let's see, what should I do for the midterm? I'll probably have a place that you could copy them as well if you can't do it on Windows. So, Stuart, is yours not working for these special symbols? If so, I'll probably have a place on the midterm where it has this where you can copy it. So let's see, abstract keyword as well as the special symbols must be italic and boldface as well. If I put this on a method, it would not be bold. So if I put this on a method, it would not be bold, but it would still be italicized. The only reason it's bold is because it's up here on the class. And then I would come back to the code and I go through the methods or the fields here. So you see I have private, static, and number of pets. So I'll come back here and this is a private method, so I'll do a minus. Okay, you can always come back to your UML PDF if you don't know them yet. So UML PDF private is minus. So I come over minus, it's a private static. It's called number of pets. It's an int and it has a default value of 0 and it's static, so we need to underline it. Okay, so I'll select it all and underline it. So it's public static int number of pets, and then do we set equal to 0? We set it equal to 0, so it has a default value. So you'll see that here in the UML. Let's see, it says Windows unstable to paste that key combination into Draw.io directly, so it opens another browser tab and pastes the special characters into the search bar. Really? This probably won't work in a lockdown browser, so for Windows, we'll definitely need to copy pastable symbols, okay? I can take care of that. Now, if I'm going to do another field, what a lot of students will do because they're in a rush, they'll hit enter. If I hit enter and start typing, you'll see it's all underlined. So if you want to create a new field, make sure you hit this little arrow on the right. You'll see a little plus symbol comes up. You hit it. Now I can remove the underline. If I do an enter here, let's say I did an enter and I put all my fields there and I move it down to increase the size, there's no way I can get rid of the italics, and you're going to have to redo it. Okay, you're going to have to redo it all. So the students will do all of the fields, then they'll come back, they'll try to unitalics this one, and it unitalics everything. So if you want to do multiple fields, slow down a little bit and make sure you're clicking the arrow. Okay, you could either draw this with me or you could take notes. That's something that I would probably write down. Make sure you click the arrow, and now I can write the next field. So if I come back to the code, it's a private string name with no default value. Private's already there, so it's called name. It's a string with no default value. Then the next one, they're all private, which is awesome for me because it saves time. This is going to be a type, and this is going to be an integer. Go to the next one. Let's see, we have name. I forgot age. I guess this one should be age. This one's going to be type, which was a string. And then this one's going to be gender. Okay, which is going to be of type gender. So you see I'm using that arrow. Now I'm going to do the methods. So if I did the methods, the first one starts with the constructor. Okay, here's the first one. So you literally go line by line down the code. First one is the constructor. So I'll come back over here. It's a public constructor called pet. The first one has no parameters. It also has no return type. But I do need to put that special annotation there for constructors. So I'll put the constructor annotation there. I see a lot of people in the industry have mixed reactions about this. A lot of people say this may not be necessary because constructor can be determined by the name of the class. But for this class, you will put the constructor annotation there. Okay, so put the constructor annotation there. It's easy for the TAs to read to make sure that you've implemented everything correctly. But in the industry, you will get a mixed reaction about this. Some people like it. Some people say it's unnecessary. And remember, in UML, you want to write as little as possible. So some people say, well, this can be removed because it's the same name as the class. Okay, but for this class, go ahead and put it there. The next one has parameter list. Okay, so it has a name, which is a string, has age, which is an int, has type, which is a string, make sure they're in the same order, has gender, which is a gender. No return type. Let me make sure name, age, type, and gender. Name, age, type, and gender. So it looks good. You'll see I have to open this up because it gets cut off. So if I open this up, it's okay for your class to be really large. If I scroll out a little bit, I can actually move this class and create more pages here. So now I have 2 pages. Now I have 4 pages. So it's okay for this class to be really large. So go ahead and make it nice and wide so you can see it all on one line. Some students will put it on 2 lines. That's really hard for the TAs to grade. So don't put it on 2 lines. Just have 1 line and make it really long. That's fine. Okay, then I come to the next method. I'm going to draw another class. We're not going to go over all of them. You'll see next one is, I'm just going to do these 2 right here. Number of pets and set type. Okay, so it's a public. Okay, so I'll leave it public static. So now we don't need this constructor keyword anymore. It's called get number of pets. Okay, it takes no parameters. No parameters. and it returns an int. Now this is a static method, so remember, it must be underlined. Okay, so static is underlined. Going to the next method. Okay, so make sure you're using those arrows or plus symbols on the side. Last one for this class. This one's called set type. It takes in a type, which is a string, and it does not return anything. So remember, if it doesn't return anything, you don't have to put void there. You just don't specify anything. Okay, now let's talk about relationships here. So let's say I have pet, that's the superclass. So I go back to the code. Pet is the superclass of, let's say, dog. You'll see dog extends pet and also implements licensed pet and trained dog. So I need to show this relationship here. So if I come over here to the right, you'll see they have different classes. They show interfaces there, but they're not really good. For each element, you'll always use this class diagram, even if it's an interface. Okay, so I'll bring it out here. I'll always use this class diagram. The thing that you want to remember is the superclass is always on top. The subclass is always on bottom. These arrows, if I go back to the slides, arrows will always point up. Okay, so I open this back up. In all the examples, you'll see the arrows at least point up. They may be diagonal. So like here, they're diagonal a little bit, but they're still pointing up. But here, they're always pointing up. And that shows your hierarchy structure. So you'll see this is an interface. Then I have an abstract class, which implements that interface. Then I have a concrete class, subclass, that extends that abstract class. So it's always pointing up. If your arrows are pointing down, you will get points deducted. So this is going to be class dog. And the arrows are down here. So you'll see it says implementation. And if I keep looking, you'll see here it says extends, generalization. So I'll drag this arrow over. You'll see dog extends. And when you do the arrows, click them. So I can just leave it there. But if I click them up to it, you'll see it turns green. So that means whenever I move these objects, see how it turns green there when I get it right on that circle? So now when I move them, the arrows move with it. Okay, so click them and make sure your arrows are pointing up. So you see dog extends pet. Dog also implements license pet. So let's say I had an interface over here. Let's say I call it licensed pet. Remember, an interface has the interface annotation. Okay, so write it in there, do the little orange deal, bring it down, and then you'll look for the one that's called implementation, bring it over, and then what I like to do is, you'll see how it says the keyword extends here. I also told the students to make sure you write implements on the line. So you can see I can double click in the middle, which has some text there. And then I can write the keyword implements. Now you don't want to have to do this for every line. So if I need another implements, I'll just copy and paste it. Then you can see I can have another line. So I can just copy and paste it. That way I don't have to write implements on each one. Okay, but you'll notice my arrows are in an upward motion. If they're straight up, it would be even better. So I can actually bring the bottom maybe over on the corner a little bit more. That actually is a little bit better in my opinion. Maybe not all the way on the corners, maybe right here on this one. Arrows are pointing up. You'll see dog extends pet and implements license pet. Let's see, every time I click on something in Draw.io, I keep getting an unknown error. It interrupts each time I try to edit a part of a class. Is there something I can do to stop that? I've never seen that before. You may try to close the browser out, but before you do, make sure you save it. So here, let's say I'm implementing the challenge, which I'm going to release tonight, and it's getting late. I've done enough for today. Make sure you save this, because when you close your browser, this is going to be gone, and you're going to lose your work. So make sure you click on File. I always do a Save As. Okay, I do a File, Save As. And then you could keep track of versions if you want. So you could keep track of version. You could say this is version 2. Or you could use Git. You could use Git to keep track of your versions. Or you could just keep overriding the previous one, whatever you want to do. I'm going to call this version 2. Make sure you save it before you close it out. Kyle, what I would do is close your browser out. If that doesn't work, you can always do a Control-Shift-R or Command-Shift-R. That will do a hard reset and empty the cache for that page. The last thing I would try would be opening up in an incognito window. So you can click on the little circles over here and do a new incognito window and see if that helps. Let's see, Daphne, does implements on the arrow need to be capitalized? I believe it should. Go ahead, capitalize it. I'm not sure if these annotations need to be capitalized. Let me go back and check. Capitalize the implements on the arrow. The annotations do not need to be capitalized. So if I go back to my annotations, up here at the top, you'll see they're not capitalized. We could keep drawing more, but I'm hoping that you get the idea. There is one thing that you'll want to know is that we have this gender enumeration. Okay, we have this gender enumeration. If I go back to my UML PDF, they have the relationships here. So generalization, that's extends. Realization, that's implements. So they tell you how to do that. But they don't really tell you how to do the relationship between this enumeration here. I have some readings that you'll want to do. It's right here. All you need to know about UML. It's by Paul here. Okay, Paul. He has the examples. That's what I use for UML.pdf. And then they talk about the relationships here. You'll see dependency. It's very loose relationship, so it's very rarely used. Association. It says if B is passed to a method of A, you'll see aggregation. A has fields of type B. Composition. If A is destroyed, B is also destroyed. So you need to read these and figure out what relationship to use for this enumeration. Okay, and actually if you scroll down, I like this article here. If you scroll down, you'll see there's another article here by Allen. Okay, you'll see there's another article by Allen. This is a great read as well. Okay, so if you go through and read this, it may take some time to load. It'll also give you some examples and it'll help you with that enumeration. The arrows do not have to be straight. That's a good question. So I can bend this arrow. I can bend this arrow, but it needs to be upward. It still needs to be upward. If I put this interface down here like this, you're going to get points deducted. If it's to the side like this, you're going to get points deducted. But if it's upward like that, then you will not get points deducted. Okay, good question, Meredith. All right, let me get you for the attendance. Okay, put your name and pop in the chat for the attendance. Work on UML. Make sure you save this so you have an example. Do a file, save as. Make sure you're saving your challenge. That way you don't lose your work. If you lose your work, you'll have to start all over. So don't lose your work. Make sure you save it frequently. Okay, that's it for today. Put your name and pop it in on the chat. I'll get you for the attendance. My office hour, I believe, will be at, let me check. Office hour today will be at 3 o'clock if you need me. Later on this evening, I'll post the challenge. It'll be John UML's. You'll also want to start preparing for the midterm. I'm going to put up the study guide here soon as well. So you want to start preparing. Go back over the object-oriented concepts we learned at the beginning of the semester. Grades for 6 and 7. I think 6 are done. I'll try to release them here soon. 7 we're still working on. Okay, so I'll try to release 6 later this afternoon as well, as long as the TAs are finished with it. But I believe 6 is done. 7 is not. Okay, that's it. Put your name and pop in on the chat. Then we'll see you on Wednesday.